Thank you. Hi, everyone. Thanks for coming. I hope you're not all feeling too Vegased out, so good effort for hanging in there. So today we're going to talk about something maybe a little different. Geocoded datasets. Bit of a complicated title, but it's actually quite a nice content to talk about. So let's start off with, why do we do this, right? Why do we do a geospatial insights platform? A few things that we learned from building this in PwC. Geospatial is difficult. Okay, if you think of the cost and the complexity of building geocoded spatial data, so you're looking at data sets that come from multiple sources, pinning that to exact geographical locations, takes a lot of compute power, and building that data set is difficult. Okay, the business case. This is something we've seen a lot within the firm. Developing a business case for geospatial is difficult, right? There's a lot of different use cases that you can use that, whether that's for building, for regulation, for telecoms. We've actually seen a lot of industries now are developing very niche, specific geospatial solutions for each industry sector. So what you end up with is 1,000 different solutions, and actually not one solution that you can grow and scale as an enterprise platform. So it's really important to get that foundation right. Data. The biggest thing behind any geospatial project is always the data. And trust me, we went through this. The data comes in every size, shape, and format that you can think of. And wrangling that into a consistent format that you can use in a geospatial context takes a lot of effort, takes a lot of processing power, and is difficult to get right. We'll come on to that a little bit. Where you get that data from as well. If you're using this in a public context or for an enterprise application, you've got to be really specific and really sure that that data is accurate. So whether you're buying that, whether that's something that's free, do you trust the validity of that data? The time frames of that geospatial, you know the rate when you go into Google Maps and have a look at something and it's still a picture from 5 or 6 years ago, making sure that's up to date, really, really important to make sure. And then making sure that the timescale within that data is up to speed. To give you an idea, we had 3 terabytes of geospatial data just to pull sort of the London point of interest together. So there's a lot involved in that. So why should you worry about geospatial? So if we look in the UK, guess by the accent, that's where I'm from, the UK government invested £1 billion into the Geospatial Commission. It's a real growth area within the industry, goes native with cloud and data services. And they reckon in the UK, it's a $17 billion business, as we start looking at that. A lot of fragmented niche solutions. So this is really what spurred us on inside our lab environment to build an enterprise platform that we can scale across multiple business types. So how do we do that? The answer is with difficulty. We had to fail a lot before we learn, before we got this right. So sourcing the data was the single biggest thing to start with. Now, when we built this, we sourced data for a number of areas. So we had Transport for London, so that's the data set that uses all the trains and tubes and overground and underground and boats, the cable car, if you've seen that. All the data, that came from Transport for London's ERP system, SAP. We used Uber data, so where cars are driving around the city and the routes. ClearScore data, what are the earnings, the average incomes of those people as they're walking around, commuters coming in and out. Census demographics, how many people live in the city, how many are commuting in and out, and then being able to pull all of that into a geocoded set, really complex. So you've got to think about the data sets you want to bring in. So what we used for this was a huge amount of glue jobs to conform that data. The first format was bringing that data in a range of formats and building that into Parquet form. We did that using glue, data brew, and slicing the data into the right shape. Once we had that in, we can then use Amazon step functions. We actually use glue data brew again for this to add the geocode data. So you think for each piece of data, there now needs to be a geocode associated with that data for where that data point exists on a map. So a vast amount of processing involved in that. Now that you've got that, we could let the data science team loose to start building the aggregates. And if you start thinking about the sorts of aggregates that you need for income versus basket size in supermarkets versus car ownership versus how many children they've got potentially, and even mobile phone data about where people are going. This is public available information. Putting that together was particularly difficult, and the data science team pulled that together. We actually had to almost develop a new role because we needed data scientists that could learn geospatial and then also learn how to pull that together. So we kind of created a new role within the company to be able to do that. So that was the main step as we went through. The main tools that we used Athena to do the data set analysis. I mentioned before, Data Brew is the key tool for the cleaning up. It takes 24 hours to run this, by the way. There's that many data points to go through. And duped to notebooks originally to start doing the data joins as we start joining the geocode sets with the raw data. So a little bit of an overview on the high-level architecture there. If you look at the type of data that we put in this, if I just reel a few off, I mentioned census and demographic, retail spend data. So we've got all the data about all the UK retailers, what the footfall is, when that footfall is, what the average basket size, how much people are spending, education levels of people coming in and out, traffic data, footfall data, household statistics, property value, income data. You start to get the idea of the complexity of all the data sets and the joins needed to do that. So 130 billion data points sitting in that S3 bucket underneath that we use to run the queries over the top, over 600 unique metrics. So to give you an idea, it takes about 24 hours to run a refresh. And keep an eye on the cost as well. That was another learning. So it costs us about 8 to 10 grand to run all these data sets. There's a couple of grand to reset this every time in compute. So it's definitely something to consider, the size of the data and what you're going to need in there as you start building that geocode set. So you've probably seen something similar before, a series of conforming sets as we brought the data in, turn that into raw format, conform that into Parquet format, brought that into a Glue data catalog, cleansed that data, then brought it through and merged it with the geocoding sets. So a lot of crawl functions to bring that together. As we go on, this is what the end architecture actually looked like at the end. So the data platform in the middle there, you can see we've got SageMaker over the top. So SageMaker is running the majority of the queries within the platform. Glue, I've mentioned before, doing the step functions. And then obviously lake formations underneath where the core data is. One thing we did find, so if you're ever doing anything this big, you can actually max out glue joins, we found. We hit the ceiling on what glue can cope with. So actually switched using Redshift serverless. That's an in-memory join model in that, so it could cope with the updates a lot quicker. So just something to keep in mind if you ever bump into that one. Now for a bit of fun, we developed a couple of front ends for this. So we've got a web front end, which I showed in a little bit. And then on the other side, we thought, let's have a bit of fun. We 3D printed a 1 meter by 1 meter map of London, three-dimensional printout. It took a while. And then actually what we can do is project the answer as heat maps over the top using the query. Okay, something a little bit different. Obviously, that's not particularly portable, but it looks great, right? So it's a really, really good demo to be able to show. So if you want to come over to our booth a little bit later. And for that, we actually use, those of you familiar with it, Uber's H3 framework. So this is a geospatial algorithm model. Some of you may be familiar with, if you're keen outdoorists, you'll know what 3 words, right? Well, the whole world's been sliced up into squares, and you get those random 3 letters that describe that 10 by 10 square on a map. So the Uber H3 is similar to that, but it uses hexagons. So for those of you into maths, you'll know hexagons are the cleanest way to fill an area, and actually means it's the shortest area between 2 points if you're doing triangulation. So if you cover the whole world in hexagons, we ran that at 3 different resolutions, and we go down to 50 square meters resolution on each one of those. So that's how the geocode framework works using that Uber H3 framework. So that's an open source available model. We also, for a little bit of fun as well, using Sumerian, added a VR mask. So you can actually physically walk around in a VR mask, walk around London and see the data sets as well. So it's nice from a front end. The web front end being the main one that customers are using, and we've got this live with a couple of organizations now to actually use it for their particular business case needs. So little bit of fun here. When we printed the model, so what this did, we printed the model out, and I should just note this was biodegradable plastic, so actually this model of London will go in the bin and will decompose, so just for the record. Printed that out, and this was done using a VR map over the top, so we can make sure that that geospatial answer was exactly accurate with the 3D model with a laser projector over the top. So just a nice way of presenting that. So again, if you come over to the stand, we can show a little bit of that and give you an idea of the front end of how that works. So on to what this looks like. So this was actually shot using my iPhone. So this is actually what it looks like projecting over the model. So what we have here is a calibration run. And what the projector's doing is calibrating pinpoints. We actually used our office as a waypoint here. calibrates the model over the top of the model, and we're able then to make sure that the model is then lining up with the data points over the top as it's projected. And you can see here the hexagon squares. So this is sort of resolution 1 coming down to resolution 2. So when you go in and start running queries, what the system can do then is project heat maps within those hexagons, showing whether you're looking at income or population or whatever the data metric is that you're looking at. You can see the grid cycles. It's actually quite nice as well. We can do time shift data as well. So if you're looking, for example, at footfall or cars, we can actually project those going up and down the river or across the major roads in London as well. So we can factor that into the calculations. So you might ask, okay, bit of fun, why did you do this? So here are 3 examples that are actually being used now with this technology. So example 1, food retailers. So you're all familiar with sort of superstores, supermarkets, the big stores, but increasingly now, especially in cities, you're getting pop-up stores or the little hand carts coming in. The grab and go, like the Amazon Go up the corner, these sorts of pop-up technologies are appearing more and more now. So what we're able to do is work with the big retailers to understand where's the best place to put a pop-up store, build a new store out of town, build a new in-store, mini-store, and start to use this sort of technology to be able to frame that question. So in this example, you can see there's a bunch of table references here. So we're looking at transport links. You know, where does the transport come into that location? Are people driving in, people coming in the train, people coming in on bus, people walking? Start to get an idea of what sort of footfall you're going to get and by what means. Competitors, really important. If you're going to build a new store, you want to make sure you're a respectable distance from your next competitor. Right? It's no good building something next door. Okay. What are they spending? So if you can understand, maybe it's an inner city store, what are they spending, or a snack or a lunch? What would be the price point you need to hit? Meal deals. We're now sort of starting to get into sort of commercial models now to understand what to sell in that store based on the income, number of transactions, number of households within that demographic. So we kind of learned that within a large store, you're dragging people around a 10-mile radius. In a smaller store in the city, you've probably only got a kilometre or 2. That's as much as people are prepared to walk to be able to get to the store. So you can start to look at the footfall around that. And the number of businesses around, how many people are going to be attracted into that area. So it gives you a little bit of an idea. So this at the back end, when those are selected, builds a query, and that query then runs on the database, comes back, and you see the answer coming back up. Similar model with a coffee franchise. You probably think, well, I must admit, coming to Vegas, I thought, who needs more coffee stores around? It turns out we do, because I don't know about you, the coffee queues have been enormous. So working out where would be the best place to put a coffee store, based on where maybe the competition are, Starbucks, others available, Costa, etc. To be able to work out, again, locations, type of transaction that they're doing, how much they're spending, number of households. So really important from a competitive perspective. So another one, this is actually being used as well at the moment. And then the last one bring out, this is one we did actually in London, is as a bit of fun, run a query to go, right, if you want to get a pizza and a beer on the way home, what's the best way to walk home and take the public transport? So you can start to build those query strings based on your present location as well. So again, we can look at what people are spending on dining out, alcohol spend, snack time spend, tech spend. I'm sure the Apple Store's been very popular in Vegas with all of us in town, so I'm sure they've seen some lovely statistics coming as a result of the conference running. This is the sort of information that geospatial can start to reveal. So a few examples there. So what I might do, if we could switch to the laptop screen. There we go. Show you the web front end. Now, as always, live demos on an open Wi-Fi connection, so bear with me on this one. So this is our GeoHub front end. So a few different options that we've got. I just want to show you an example of the Explorer front screen, assuming it hasn't timed out because my laptop went to bed. So here we go. So I want to start building a query. So let's have a look at what that. So what I'm going to search for is a co-op food store. So this is a retailer in the UK. Now, immediately, the database knows the associations with the joins, and you can see it's recommended all of the other associated competitors within that category. So this is metadata results coming back. So I can simply say, yes, I'd like to bring all of those competitors inside. But there's a number of different areas that I can search. Industry, education, grocery, healthcare. This is all part of the data in here. I can look at the categories as well, whether that's cars or cinemas or dentistry. So a lot of data points on here, as you saw earlier in the presentation. So I can start to build my source data that I'm interested in. Great. So if we've got that, I can now go, right, what are the geospatial drivers that I want to look at as part of that? So potentially, I might want to look at maybe a competitor spend, right? And I want to look at that within a kilometer's radius. Or I want to maybe look at income. So what's the discretionary mean income from a household? Or looking at maybe the basket size, median monthly income, and we've got maybe something like footfall. Food and spend transaction, there we go. So as you can see, you can start to build up your query here and choose the distance that you're going to run that query against. So let's just click on next. So look, there's the core summary of the query that we've got running. So if I run this, there, you can see, right, that's looked over 24 million data points in about 1.5 seconds. So that's quite a good response time. The number of entities, this is the query results on here. Now what I can do is I can look at this as a map. So if I come down to London, wait for the data to refresh. This is where we're at the mercy of the Wi-Fi. It's now loading up the geospatial data for that area. What I might do is jump just across to another one that's come in here. So this is a similar query that I built just before with that data preloaded. And now that I've got this, I can start to look at some of this information. So let's look at the peak density visits. So now you can see these hexagons. If I just come in, you can start to see the data coming in here. So looking at the density of visits per week, I can now start looking at the unique data sets for that 50-meter area hexagon in the middle of London. So I can start to look at the impact of that location. I can overlay other information as well. So if we look at traffic, so if I turn that on, and you can now start to see this is where the main footfall and traffic is coming through. And you can see there that's actually chasing some of the major conduit roads coming through London. So you can see here, so if I pick one of the darker colors here, you can see here we've got a much higher density of visits and footfall, maybe in one of the quieter streets. Obviously, you can see that's less than halving by comparison. So it's a really powerful way of starting to overlay that data and looking at different models to be able to pull that together. Different views, of course. You can do satellite views and different overlays on top of that to get some different perspectives. And of course, if you're into your data, you can actually then go and look at the raw data behind that. So here it all is, and even pull that down so you can import that into other analytics or areas. So I only had 15 minutes, and honestly, there's so much to talk about on this, but I hope that gives you a little bit of an insight into the world of geospatial and the platform and why we built it. If we switch back to the slide, just some contact details here. If you've got any questions, want to double click on this, get deeper into the tech, have a look at the solution architecture, we'll be over at the PwC stand just to the right-hand side there. But other than that, thank you for your time.